everyone, welcome you all in my YouTube channel Engineering Guru 29. In this video, I will cover Carnot Vapour cycle and also explain the various process of Carnot cycle, limitations of Carnot. Let's see one by one. Carnot Vapour cycle. In Carnot Vapour cycle, steam or any other vapor is used as a working substance. The schematic diagram of the Carnot cycle is shown in figure. It consists of two isothermal operations 1, 2 and process 3, 4 and two adiabatic operation process 2, 3 and 4, 1. Here this is the schematic diagram of Carnot Vapour cycle. This is boiler, heat is supplied Q1, this is steam turbine, work output, this is condenser, heat rejected cooling water, this is cooling water in, and this is pump. So this is called Carnot Vapour cycle and this is the main component of this Carnot Vapour cycle. Now understand different types of process. So for this, first of all consider 1 kg of saturated water at the pressure P1 and temperature T1. First one, that is the isothermal expansion. It is also called process 1-2. Heat is supplied at the constant temperature and constant pressure P1 in the boiler to convert 1 kg of water into the dry system. So the isothermal expansion process is represented by the 1-2 in figure A and B. Now, so this is figure number A. This is for PV diagram and figure number B is for TS diagram. In this diagram, we observe that this is the point number 1 and this is the point number 2. So heat is supplied to the boiler and it convert into the steam. So this is the isothermal heat addition in boiler. Isothermal process having T1 equal to T2 means constant. Here TS diagram we can see that the point 1 and point 2 in same line. So here T1 equal to T2. This is also called constant pressure process because we can see that the point 1 and point 2 both are in same line. So here this is the this is called P1 equal to P2. This isothermal expansion, it is also called constant pressure process. The saturated water at point 1 in isothermally converted into the dry saturated steam in the boiler. So this is the process 1-2 isothermal expansion. Another process, this is adiabatic expansion process 2-3. Dry steam at point 2 now expand adiabatically in steam turbine. The pressure falls from point P2 to P3 and the temperature T1 to T2. Since no heat is supplied or rejected during the adiabatic process, there is no change in entropy. The condition of steam after adiabatic expansion is represented by the point 3. The process 2-3 is shown in figure A and B. Now understand, this is point 2 in PV diagram and point 3. So we observed that the pressure falls from point 2 to 3 means P2 to P3. Same in TS diagram, this is point 2 and this is point 3. So temperature falls from T2 to, there is no change in entropy. In this schematic diagram, we can observe that this is point 2 and this is point 3. So this is the reversible adiabatic expansion from steam in turbine, and the dry steam at point 2 expand adiabatically in steam turbine and turbine develops the work WT. So we can say this is the work output. Process number now 3-4. It is called isothermal expansion. The waste stream at the point 3 is condensed in the condenser and heat is rejected at the constant temperature T2 and constant pressure P3. This process is shown in figure 0.34 in figure A and B. First, This is called isothermal compression. So two isothermal process. First, this is in 1, 2 and this is in 3, 4. Here we can observe that this is 0.3 and this is 0.4. So both are in same line. Here it is P3 equal to P4. Same in TS diagram. This is 0.3 and this is 0.4. So both are in same line. So that's why it is called T1. This is called T1 and this point is called T2. In this schematic diagram, we can see that this is the 0.3 and this is 0.4. This isothermal heat reduction in the condenser converts steam into water at the constant pressure and temperature. So this is shown in figure PV diagram and TS diagram. Now, final step, final process.
First, open YouTube and write down Engineering Guru 2020. Search. This is Engineering Guru YouTube channel. Open this and subscribe this for more update. Various playlists available here. You can see this is for various subjects. This is for velocity diagram, uniform velocity, for chem profiles, synthetic linkages, and more playlists are here.
Now, final step, adiabatic compression. The condensate at 0.4 is pumped by the pump adiabatically till the steams come into the initial stage of temperature T1 and pressure P1. Since no heat is absorbed or rejected during this process, entropy remains constant. This process is represented by 4:1 in figure A and B. I will share some most important points. So many YouTubers, so many books. Here it is shown. This is compressor. But in Carnot Vapour cycle, pump is used. Why pump is used? Because after condensate, water and some amount of heat enter into the pump, and this pump the water into the boiler. So that's why here the pump is used. So this is called, so here this is 0.4 and this is 0.1. It is called isentropic compression. Pressure is increased from P4 to P1. The steams come into initial state at pressure P1. Same, this is 0.4 and this is 0.1. So temperature will increase and it will initiate initial state at temperature T1. So remember these things. The main component of Carnot Vapour cycle is boiler, steam turbine, condenser and pump. So this is the Carnot Vapour cycle. Here we see the PV diagram and TS diagram of Carnot Vapour cycle. But remember, most important thing is that this is the main component Q1, main component steam turbine and condenser and pump. So remember this thing, in Carnot Vapour cycle the pump is used. So as we discussed that Carnot Vapour cycle consists of two isothermal operations, means at 1, 2 and at process 3, 4, and two adiabatic operations, means isentropic expansion and isentropic compression. So remember these things. This is the very important. Now work developed by the turbine, that is WT equal to H2 minus H3. This is for steam turbine. Now work input to pump, that is WC equal to H1 minus H4. Now net work done equal to W net equal to WT minus WC. Put this WC and WT value in these equations. So that would be H2 minus H3 minus H1 minus H4. Simplify this. The heat supplied during the isothermal expansion Q equal to H2 minus H1. So efficiency of the Carnot cycle is given by efficiency Carnot equal to net work developed divided by heat supply. Net work developed is H2 minus H3 minus H1 minus H4, and heat supply, that is Q, H2 minus H1. Simplify this term, H2 minus H1 minus H3 minus H4 divided by H2 minus H1. So it would be, right, 1 minus H3 minus H4 divided by H2 minus H1. QR equal to H3 minus H4 heat rejected in condenser. QS H2 minus H1 heat supply in boiler. Entropy is defined as ds integration of dq by t. So some numerical steps will be there. So now integrate the heat rejected. QR equal to T2 into bracket S3 minus S4. So we can write T2 S2 minus S1 because S2 equal to S3 and S2 equal to S1. Heat supplied QS equal to T1 into bracket S2 minus S1. So remember this thing. So heat is supplied in boiler during process 1 and 2 and heat is rejected the process 3 and 4 during the in condenser. Efficiency equal to 1 minus T2 S2 minus S1 divided by T1 into bracket S2 minus S1. So you can write 1 minus T2 by T1. So you can write 1 minus T2 divided by T1. So where T1 equal to maximum temperature of the cycle and T2 equal to minimum temperature of the cycle. Now some limitations of this Carnot Vapour cycles. First one, that is the condensations process has been stopped at state 3 so that after adiabatic compression initial state 1 is obtained, but in this situation the device will increase the pressure and has to handle the mixture of water and steam. It is very difficult to design a device which handle the two phase of fluid. So this is limitation number 1. Second one, it is difficult to operate with the superheated steam due to necessity of supply superheated steam at constant temperature. This means that heat addition and expansion of steam take place at some time. Third one, adiabatic compression of vapor require more work due to its high specific volume, thereby reducing the work ratio. And fourth one, all the processes are assumed reversible, but some losses always take place. So this reduce efficiency of the Carnot cycle. So these are the limitations of this vapor Carnot cycle. So in this video, we covered Carnot Vapour cycle, different forces, limitations and concepts. So if you find my video very helpful, you can subscribe our YouTube channel. You can join us on FB page, join us on Telegram channel, WhatsApp channel, Engineering Guru 2020. Stay on this channel. More video will become of the subject basic mechanical engineering. If you find my video very helpful, you can like, comment, share and subscribe. Thank you.